What's going on, guys? Another day, another Microsoft outage. This happened 2 days ago, actually, on April 1st, April Fool's Day. And a lot of Microsoft services just went down. Microsoft actually revealed the issue back then. It was a DNS issue, but we don't know much information back then. And I made a quick video talking about that, right? They released a root cause analysis, so I thought I'd just make a quick video to discuss this. But I think we can learn a thing or two. But I just want to go through the list of outages that they had, right? Back on April 1st, that's the latest one that happened 2 days ago. There is another one that happened March 18th. I completely missed that. I'm not sure if it was like maybe it was a weekend. Because we didn't see anyone complaining about it, but this one is the most interesting one, right? And then 3 days before, that's the one I reported on, March 15th, right? The authentication and the token bug, right? Where the token was a token was essentially incorrectly revoked and causes every single service to freak out, and they did not accept any authentication. There's another way on March 9th, or it's just Argentina and Uruguay. Not the entire war. All of these were global. Outages do happen, guys. This is absolutely normal. This is what do you do when you're serving the entire globe, obviously, right? And then you have the scale of Microsoft, obviously. Google has the same thing, and Microsoft is experiencing these challenges and learning from them and just moving on. So there's nothing we can do. It's like we're not here just to kind of poke fun at these outages. No, we're here to learn and educate ourselves as engineers so that we don't fall into it. So that if we face the challenge or a problem that we want to solve, we know what not to do, because these are just lessons that we can extract from these outages. Let's read through the RCA that happened on April 1st, and let's discuss. The title is Root Cause Analysis. DNS issue impacting multiple Microsoft services tracking ID GVY5-TZZ, or ZZ if you're in the UK. Summary of the impact. Between 9:21 UTC and 22, which is 10 o'clock in the evening, on April 1st, Azure DNS experienced a service availability issue. This resulted in customers being unable to resolve DNS names for services they use, which resulted in intermittent failures accessing or managing Azure or Microsoft services. Due to the nature of DNS, the impacts of the issue was observed across multiple regions. Recovery time varied by service, but the majority of service recovered by 22:30. So I guess it took 1 hour. That's not so bad, right? They started getting services by 1 hour. Some people experience more than that, but 1 hour is good, right? They managed to fix the issue. So what caused that issue? Right? Obviously, I was fixing my car. So I wasn't at work. I was not working, so I did not actually experience that, right? And thank you for everyone who asked me about my car. It was just a tire blown. I had to change it, and the lugs were stuck, and because of California's heat, they melted and they couldn't get it off. That's the problem. Root cause analysis. Azure DNS servers experienced an anomalous surge in DNS queries from across the globe, targeting a set of domains hosted on Azure. Normally, Azure's layers of caches, which the first thing that we thought about, right? Caches. Where's caches? Where's the cache? Why are we having DNS surge? Normally, Azure caches and traffic shaping would mitigate this surge. In this incident, one specific sequence of events exposed a code defect in our DNS service that reduced the efficiency of our DNS edge caches. As our DNS service became overloaded, DNS clients began frequent retries. We know what happened when we do retries, guys. right? This is the major problems that we have in microservices. Retries and short circuit breaking, all these things amplify the number of requests. The more requests you have, right, you make a request and the client times out, right? And then although, yeah, the client times out, but the server or the service keeps executing that request because it doesn't know that you actually timed out, right? They don't have knowledge, right, of each other, the client and the service. So now the client says, okay, let me retry. So it will cancel that request, and by cancel we mean give up. Very few services have the ability to truly cancel a request. It's very, very difficult. It's a stateful way of cancellation. gRPC supports it, but you have to do it really right. You have to get it right to cancel a request, because what does that mean? I'm in the middle of something, right? You have to have hooks on the server side to cancel a request. There is no way to do it easily, right? There's a lot of work. So by canceling here, we mean, hey, I just give up. Let me make another request. All of a sudden, you just double the amount of requests. That request now is waiting. And now imagine thousands and thousands of DNS clients doing the same thing. Obviously, it's going to become overloaded, right? As our DNS service become overloaded, DNS clients began frequent retries of their request, which added workload to the DNS service. Since client retries are considered legitimate DNS traffic, this traffic was not dropped by our volumetric spike monitoring systems. That's very interesting, because it wasn't just a normal HTTP request. It would have been detected by their monitoring and mitigation system. It's like, hey, there's a spike. You know what? That's what Slack did like a few months ago when they had in January 2021, when they had it, like, hey, there's a lot of requests. Let's kill those requests so that our service continue processing the existing one, and then let's let it in. They had to do that. They can do that because they have control over this. This is a completely different thing. That's why I think a little bit interesting here, right? It's a DNS request. You can't just stop DNS request. DNS is the most legitimate request ever. It's a UDP request, a packet, usually lightweight, and usually process very quick. But the cache misses here is what got Microsoft. Okay, let's continue. This increase in traffic led to decreased availability of our DNS service. So the DNS being resolved, let's go, if you want to go to teams.microsoft.com, imagine all of these clients trying to resolve Teams, right? Eventually, and here's how DNS works, guys, right? DNS works with multi-layers. So you will call, ideally, you will call for DNS requests. You will call your local DNS provider. Usually this is your ISP, but you can override it to be anything you want. People started using Cloudflare recently, and Google. Cloudflare is 1111 and Google is 8888. So if you're calling that, say, where is teams.microsoft.com? It will try to answer from the cache, from its cache. If it doesn't know, it will forward the request to another DNS, intermediate DNS resolver. Until this forwarding happens, until you reach what we call the root DNS server that is responsible to resolve this domain, which is Microsoft.com belong in Microsoft servers. So the authoritative DNS server is at Microsoft. And that's what happened. So the caching are not happening just at the Microsoft layer. There are different caches all around the globe, but those got timed out eventually. Those caches got stale, and Cloudflare and Google had to make requests eventually to Microsoft to get the latest DNS request. And this essentially exacerbated the problem. So what we learned here is, if you don't have cache for this, you better have a lot of these DNS servers resolve ready to process these requests, and you have to have all sorts of caching to mitigate this. Because, like, imagine everybody's calling on Microsoft, not just browsers, APIs, IoT, Microsoft Teams, and 365 services. Imagine all these services. Everybody is calling into DNS. eventually this DNS request poured into this DNS servers that Microsoft have. So what did they do? Mitigation. The decrease in service availability triggered our monitoring systems and engaged our engineers. Our DNS services automatically recovered themselves by by 10 o'clock at the evening. Sheesh, I can't read this military timing. 2200, right? Let's be fancy. 2200 UTC. This recovery time exceeded our design goal, and our engineers prepared additional serving capacity and the ability to answer DNS queries from the volumetric spike mitigation system in case further mitigation steps were needed. So they increased the amount of DNS resolvers essentially to solve this, right? Because they just couldn't keep up with the amount of load, right? It's just interesting because remember, if nobody has the knowledge about your DNS resolver, the more you wait, the worse it gets. Because if at least one or two services, the intermediate DNS resolvers, got the IP address for your DNS host, then that's not a problem. It's going to be cached downstream. But what if nobody got this stuff? All these, not just end users, intermediate DNS resolvers are asking Microsoft, and there are thousands and thousands of those, right? And if you don't get, and there are clients of those intermediate DNS resolvers that are asking Google, that are asking Cloudflare for Microsoft.com or for Azure.com or for the status.azure.com, all these DNS records. And Google and Cloudflare don't know the answer. They have to connect Microsoft, and this exacerbated the request, obviously. Immediately after the incident, we updated the logic of the volumetric spike mitigation system to protect the DNS service from excessive retries. Okay, so they started adding the logic into their monitoring system to monitor retries on DNS service and stop it, because you have to stop it at the end of the day, because you cannot just accept. At the end of the day, you're going to increase your limits, which is something very interesting happened on March. I'm going to read through that because sorry guys, I know it's going to make the video longer, but I think it's very, very interesting to read through the other piece, which I think it's not really related, but I think it's interesting. I'm not going to make another video for it. So enjoy the extra content. All right, next steps. We apologize for the impact to affected customers. We are continuously taking steps to improve the Microsoft Azure platform and our processes to help ensure such incidents do not occur in the future. In this case, this includes, but is not limited to, repair the code defect so that all requests can be efficiently handled in the cache. Okay, this is obviously one of the solution, or if not the solution. Just cache it on. And when I say cache here, we're talking about caching at Microsoft side. We're not talking about outside cache. Outside cache is taken for granted, obviously. That's without saying. We need to cache at the edge of Microsoft servers. Improve the automatic detection and mitigation of the anomalous traffic pattern, which they did, right? They mentioned that. All right, so let's go through this. The other one, I think you're gonna enjoy this. This is really good. Azure Key Vault intermittent failures. So they had on March 18, they had another outage where a subset of customers experienced issues and encountered error message internal server errors when accessing their vaults in West Europe and North Europe region. Oh, it's only on Europe. Okay, there was only on Europe. Only on Europe. It's basically half the word. These errors were directly impacting customers performing operations on the control plane and data plane for Azure Key Vault, or for supported scenarios that use customers manage keys for encryption or the rest of Azure resource providers, in which case those resources will remain available. So what happened really here? I just want to read the blurb that I'm interested in here. This is relatable to me. This happened to me. That's why I would like to read it to you guys. And I think, yeah, you're going to enjoy it. Root cause. Azure Key Vault microservice that handles storage transactions in West Europe region was impacted by a high CPU usage event in one of the processes that runs on the VMs. So there's a microservice that handles this Azure Key Vault, and it's running on one of the VMs. And where do VMs live? They live eventually on a physical machine. So you have this one physical machine, this bare metal that is hosting maybe thousands of VMs, and there's one VM that have high CPU usage. The resource utilization of that process was not constrained, and it impacted underlying machines supporting Azure Key Vault service at 11 o'clock. Wow. Because that VM didn't have any constraints that, hey, you can grow as large as you can. That's what she said. And basically, because you didn't have any limit, the VM just took over the whole machine. And the rest of the VMs that is in that same physical machine starved to death, essentially. And then just basically stopped responding to other stuff, which kind of, we saw this downstream behavior of one thing leads to another thing leads to another thing. All right, so that's very interesting. This is very, very common. I've done this before, where a VM just didn't have any constraint by default, and there's, well, just, why is this thing not working? Right? It has nothing to do with it. Just, if you go to the VM will report, hey, everything is happy and dandy, right? Because the VM says, hey, I'm not doing anything. But outside CPU, the outside machine is being pegged by one of the VMs, because the VMs actually took all the resources. The increased CPU utilization led to connection drops to the other backend system. Makes sense, right? It's like once you don't have CPU to process packets that comes in, you're done, right? Hey guys, Hussein from editing. As I started reading and editing through the video, now I'm not 100% sure what really happened. So now here's what happened. We have a process that is running in a VM, and that VM is sitting besides other VMs on the same physical machine, right? That single process running this Key Vault microservice took over and hit 100% CPU. Now, did it take over that single VM that is this processing on? Or did it even go further and took over that VM and went all the way and took over the processes of that machine itself, the physical machine? That I'm not sure about, so I just wanted to clarify that. I think it's the earlier, where the process took over that VM. The other VMs in that physical machine, I think it remain intact, but I could be wrong. It's not clear from the article. Let me know, what do you think? Back to the video. You will see other services start to fall down. The monitoring system detected the failures and triggered an automatic failures of the West Europe services to North Europe. At Vault in West region were then limited to read-only operation. So it was limited to read-only operations. West Europe VMs for the microservice continued to be unhealthy, and North Europe served the traffic for both regions. So it shifted to North Europe, right? So there was like some sort of a failover, I guess, and then now all the requests flipped to the North Europe. The same background process experienced high CPU usage in North Europe. At this, now North Europe just kicked in the same bug, not bug really. It's just that North. We know that West Europe just got screwed, right? Now failover took over. We went to North Europe, and North Europe now have the same problem. One of the VMs, high CPU, the underlying machine just died, and all the VMs just die as a result, living on top of that physical machine. Again, I don't think that's what's happened. I think the VM that the process is running went down, and all the microservices running on that VM went down with it. The other VMs that has nothing to do with that VM should remain isolated. Again, That's just a speculation. At this point, the failures across both regions caused an outage for both read and write. Okay, because you can't even read. You were able to read, but now you can't even read or write. Availability of vaults in both regions. While working on this mitigation, the automated systems triggered a series of failures, failovers, and failbacks. So guys, this only affects if you were unlucky and your to-do microservice lives on a VM that happens to be in the same machine that this key vault is in, your application is done, essentially. So some lucky services were not in the same physical machine as a key vault Azure, which makes sense. Like, as you distribute things, it's good to distribute the things kind of randomly and don't put things consistently, right? Because I know the other machines continue working normally, right? Because they don't have this one key vault thing that just took over the whole machine. The automated system triggered a series of failovers and failbacks, which led to the service switching traffic between West Europe and North Europe as each region alternate, becoming healthy and unhealthy with shifting traffic. So they just like back and forth, back and forth. Mitigation. At the first measure to remedy this the situation underlying VM supporting key, guys, what would be the measure? Should be limit the VM so it doesn't increase. Like, hey, you can only have one CPU or two CPUs. And hey, you can only consume, I don't know, 50% of the CPU. You cannot do more than that. As a first measure to remedy the situation, underlying VMs supporting Azure Key Vault were rebooted. They just rebooted the whole machine. However, the CPU usage continued to be high in the VMs. Engineers then deployed new VMs with higher capacity to handle the increased CPU usage. Oh, so just deploy a new CPU, okay. And redirected traffic to them. Once this was completed, both regions recovered. Also, as a preliminary measure to prevent recurrence in other regions, the capacity was increased. So they just increased the capacity. Interesting. Why wouldn't they limit? Okay, that's weird. Let's continue reading. Maybe they will do it here. We apologize, blah, blah, blah. The first precautionary measure taken was to increase the number of VMs and capacity for the microservices globally to prevent outages from a similar issue. So because now the VMs, yeah, there is a problem because the VM is taking a lot of CPU. That means we need more VMs of this instance. We need more instances of this key vault thing because apparently one VM is not handling it. So spin up more. Right now, I think we need to kind of limit this from happening. All right. I guess they won't be doing it. Let's see. New monitors have been added to watch for increased resource usage from processes. Failover and failback is being constrained. What is failback? I never heard this before. Interesting. I guess failovers go to the other machine, and then when we flip back, when the other machine is healthy, we fail back. Oh, I guess that's what it means. Never heard of this before. I guess they go side by side. Okay. Is being constrained to prevent ping pong between paired region, because of this ping pong, as we talked about, fail back, fail over, fail back forever. Because if you go back and forth, that's just a lot of resources being consumed, right? Which extended the recovery time. The team is working on modifying the failover pattern for the service so that the paired region is not affected by the failover traffic from another region. So they are the failover region. When we go from West Europe to North Europe, let's dedicate certain areas in the new region, in the failover region, for the failover stuff, so that we don't take over the whole region, right? Just dedicate a new area. That's a good idea. I like it. We are looking into resource usage by processes on the underlying VMs that support Azure Key Vault and working to build capacity model and restrict high usage by a single process. Okay, they are doing it. This is just the final, essentially a final solution for them. All right, guys. I think these two, and the third one, obviously I discussed it. I'm gonna reference the video, guys, if you want to learn more about it. But this is interesting. I think I take that back. The DNS issue is actually interesting. The idea of having different kind of caches and the monitoring and the retry concept, it's interesting. The whole thing is very interesting because I never seen DNS queries taking down servers before, right? This is new, right? Maybe you guys saw something like that, but DNS is interesting. I mean, regardless of actual attacks, this was not an attack. This was just, as far as we know, this is not an attack, right? But this is just normal processes that is exacerbated by the missing cache or the defect with the caching. So I found it interesting. Let me know, guys, what do you think in the comment section below. I'm gonna see you on the next one, guys. Again, kudos for the Microsoft engineers on top of everything. As usual, this is difficult situations. If you are an engineer in these companies, kudos to you guys. I know this is a very stressful and very tough job, so thank you so much for all the engineers, my fellow brethren and sisters. Good job, and I'm gonna see you in the next one. You guys stay awesome. Goodbye.